Welcome to a brand new episode of TUMI TV, broadcasting to you today from one of Berlin's e-bus depots. How do you feel about new technology? Are you an early adopter, or do you like to observe from afar? E-mobility is no longer a new technology in the world of sustainable mobility, and its adoption in cities around the world is picking up pace. There are various sizes and forms of e-mobility, but based on the Avoid, Shift, Improve approach, urban public transport is one of the key areas to electrify as soon as possible. That is why today we want to take a closer look at e-buses with you, because when it comes to fixed public transit routes, e-mobility is one of the ideal solutions to contribute to decarbonizing fleets, better air quality in cities, and less noise pollution, especially when it's powered by renewable energies. A new technology requires different infrastructure, new finance concepts, as well as operational procedures. Looking at e-buses, replacing entire diesel fleets with e-mobility is in fact no small endeavor for cities. But more and more cities around the world are paving the way for e-bus rollout, and their experiences provide ample opportunities for lessons learned and best practices. So let's dive deeper into the issue of e-bus rollout and investigate some of the challenges, opportunities, and myths. We spoke to the World Resource Institute, one of the leading global think tanks on the matter, and asked them why it is paramount that cities start to think about e-bus rollout rather sooner than later.
Gostaria de perguntar para você como você enxerga a contribuição dos ônibus elétricos em relação à mitigação dos gases de efeito estufa no Brasil e na América Latina em geral.
Bom dia, muito obrigada pelo convite para estar aqui com vocês. Eu acho que sim, a gente vê que o setor de transportes é um dos principais setores emissores, tanto no Brasil quanto na América Latina, né? O setor de transportes no Brasil, dentro dos levantamentos, que é dentro do setor de energia, que é o terceiro principal setor emissor, e dentro desse setor de energia, transportes é o principal deles, né? Chegando a contribuir com 90% das emissões de poluentes e dióxido de carbono são oriundas do setor de transportes, quando a gente está falando do setor de energia, que é o terceiro setor mais poluente. Então, a gente vê que tem uma grande contribuição. E o mesmo acontece nos outros países da América Latina. A gente tem alguns índices de 2014, que principalmente Brasil e México se encontravam entre os 10 países a nível mundial com maiores emissões provenientes do setor de transportes. Então, a gente mostra a relevância que o setor de transportes tem quando a gente está falando nas emissões de gases de efeito estufa. E tem outros exemplos, o Chile também tem como grande emissor, a Colômbia também, então não é uma questão só do Brasil, mas sim na região da América Latina é bastante preeminente o setor de transportes para emissões de gases de efeito estufa.
E como os ônibus elétricos aparecem como uma opção, né, de mitigação dessas emissões, qual o potencial, né, dessa tecnologia, da inserção dos ônibus elétricos nos sistemas de mobilidade urbana, de contribuir para uma redução dessas emissões ao nível do Brasil e da América Latina?
Mais um ponto só para acrescentar, acho que quando a gente fala da parte de cidades, essas emissões ainda são mais significativas ainda do setor de transporte, o que faz com que o ônibus elétrico tenha mais razões ainda para ser implementado, né? Quando a gente está falando no setor de transportes nas cidades, a gente vai para casa dos 60% das emissões das cidades relacionadas ao setor de transporte. Então, quando a gente fala da substituição da frota de ônibus de combustão interna, que ainda no Brasil tem uma tecnologia mais antiga que outros países do mundo. Aqui no Brasil a gente ainda tem ônibus Euro 3 rodando nas ruas, Euro 5, então a gente ainda não está no padrão mais avançado de emissões de poluentes. O potencial dessa substituição por ônibus elétricos, ele é muito grande. E a gente está falando aí de uma frota muito significativa no Brasil, né? Já que a maior parte dos nossos deslocamentos nas cidades brasileiras são feitas pelo sistema de transporte coletivo por ônibus. A gente tem uma frota de mais de 100 mil ônibus que tem uma idade média já avançada, algo entre torno de 6 anos hoje em dia, talvez um pouco mais. Com a pandemia, esses ônibus estão ficando cada vez mais antigos porque a renovação deu uma desacelerada no seu ritmo, então a gente está com ônibus mais velhos nas nossas cidades que aumentam os fatores de emissão. Então a importância da gente transicionar para ônibus elétricos se torna cada vez mais essencial, até porque os poluentes associados nas áreas urbanas, muitas vezes são os materiais particulados 2,5 e 10, que são provenientes da queima do combustível fóssil em veículos pesados como ônibus e caminhões, mas os ônibus sendo ainda bem significativos dentro disso. A gente tem alguns números de 2012 do Brasil, que mostram que esses poluentes emitidos por ônibus e caminhões de óxido de nitrogênio e material particulado são representantes de 91% de óxido de nitrogênio e 96% por material particulado do total emitido pelo transporte rodoviário no Brasil. E grande parte desses ônibus circulam nas nossas cidades. Então, o potencial e o benefício que esses ônibus podem trazer são muito grandes. E quando a gente fala de benefícios, daí a gente também tem outros dados mostrando que as mortes causadas por poluição do ar nas nossas cidades podem chegar a 51 mil mortes por ano de doenças respiratórias e cardiovasculares. Se a gente substitui esses ônibus a diesel por ônibus elétricos, esses poluentes que causam essa poluição do ar local deixam de acontecer. Então a gente tem aí um potencial benefício de salvar muitas vidas com a diminuição das doenças respiratórias e cardiovasculares associadas a esses poluentes nas cidades.
So you see, there's a lot of reasons why e-buses are a great solution for public transport providers. And they also help us understand why they are so popular in cities.
I've rarely seen e-buses on the street in any city. It seems e-buses remain the exception and are only affordable for cities in industrial countries. Maybe it's more of a short-lived hype than a fundamental transformation?
Well, then let's have a look at the numbers to understand how far the e-bus penetration in our cities already is. These numbers show that e-buses are not yet the dominant technology in cities, but they also make it clear that it's only a matter of time until they are.
But only a few manufacturers have really shifted to producing e-buses yet. And if cities are trying to procure buses, they have to look hard to find any number of offers from manufacturers. So are e-buses really available?
You have a point there. There is no mass market for e-buses yet, but more demand for e-buses is also going to send a strong signal to the market and accelerate its development. Let's go to our colleagues in Costa Rica who successfully managed to put e-buses on the road, and let's ask them how they managed.
Hi Andrea, so nice to have you with us today on TUMI TV.
Thank you, it's a pleasure.
So from your local experience on working with e-buses, how would you generally rate the technological readiness or even the maturity of the e-bus market globally?
For us, it was more than sufficient. The types of charging technologies on batteries, on different types and sizes of buses. Since we chose a very basic type of bus, 12 meters standard bus, battery, overnight charging, it was more than sufficient.
And how would you assess the availability of e-buses in general? Do you think this was due likely to the specifics of your project, or is your impression that procuring e-buses is still sort of cumbersome and there's not a lot of rolling stock available or manufacturers out there willing to provide?
Well, I would say the distribution is a bit complicated. I mean, there are many in Asia, especially in China. There are some in Europe. But a few of the companies also responded to us that they are not interested yet in exporting because they have sufficient demand. So they would prefer first to deliver to German or to European markets, because for them also the risk of having bad publicity if the project goes bad or if we have problems with after-sales services. So it's understandable that they don't go to international markets first. But for us, of course, it was a limiting factor. And yeah, also in the region, there's very few assembly stations for buses, and own production for e-buses hasn't or had not started when we wanted to purchase the buses a bit more than a year ago. Mm-hmm. Yeah, because of course we would have preferred to to buy a bus from the region to maintain the revenues in the region. But yeah, it was just not possible.
So how did you ultimately manage to procure the e-buses? Was it a lucky shot that someone was willing to provide the buses that you requested, or did you also adjust what you were looking for according to what was available on the market?
No, we talked again to some providers and reminded them, here there is our offer. Please participate, because also before we put the first offer on the internet, a couple of them had confirmed that they wanted to participate. And I don't know, maybe it was lack of interest because 3 buses are not that appealing. On the other hand, pilot projects also offer a great opportunity for companies. You know, if you are the first providing the bus, then also other bus companies or other public transport providers can see the good example. And also the development of after-sales services. Then once an import company has the experience, then they have some trained personnel, and they have established structures also to provide spare parts. So it's actually a very good opportunity for companies. But yeah, considering that this is a global trend at the moment and that the market is so large, I assume that Costa Rica is not the most appealing. Even though, I mean, Costa Rica has very strong climate agenda, and they're very visible, I would say, on the international podium. Not so much in transport policy, but in climate policy. And that is maybe also why finally and luckily some of the companies participated, because Costa Rica has a law on electric mobility that defines that every 2 years the bus fleet has to increase 5% of its share of electric buses. So the trend is set. And getting to the market early actually is an advantage for companies, I would say.
So would you say the fact that there is national legislation encouraging the procurement of e-buses, that makes it more interesting for manufacturers as well, because they have some sort of perspective that there will be more buses or more bus demand in that region?
Yeah, I would say so, absolutely. And it's not only this quote or this rate of 5% every 2 years, per 5% more, but it's also the exception from taxes. For example, not only the buses are excluded from import taxes, but also the spare parts and everything that belongs, let's say, to the electric mobility package, like charging infrastructure. So this is a big advantage.
And following up on something you said in your previous reply about the post-purchase services that you also required, did you manage to establish a good system on really bringing these buses to San Jose and making sure that maintenance and everything is taken care of, even though, like you said, the infrastructure and know-how wasn't really there before?
Well, what we agreed in the contract is basically that we, within a week, receive the service of maintenance if there is a certain case. Luckily, so far, we haven't had any. And I mean, we bought the buses from BYD. So BYD is a provider here for conventional buses, and so there is already, for most parts of the buses, there will be spare parts. However, of course, when it comes to the engine or to everything related to the electricity system, then let's see how it works. If we would need some specific parts for the part of the electricity, like engine and everything related to that, we depend on the sales partner in Panama.
Okay.
So everything, I mean, Panama is close. It wouldn't take long to get a technician here and also the spare parts. But with all the COVID restrictions and so on, there's a certain risk. But at least it's closer than China. In reality, even though our support partner is in Panama, but many of the questions we had to deal with during the purchase process had to go through China. So this needs to be considered. I don't know if it is the same case for all providers, but in our case, this has delayed the process, I have to say.
And so besides the availability of the actual rolling stock, what were some of the biggest challenges in procuring e-buses? So going through the whole process, what would you say was the biggest challenging part of it?
Yeah, I have to say it was to get offers to raise interest for this small purchase of buses, because we had the funding from the Ministry of Environment in Germany, the BMU, to realize this pilot project. And we would have wished that we can, let's say, bundle this money with private sector contributions from bus companies. But unfortunately, this didn't work out because they wanted to see the pilot project running first. And also 12 companies from Costa Rica signed an agreement that they would do a scaling up phase. So they would put in their money to buy own buses once the pilot project is running. So this is something positive that was achieved. Unfortunately, then Corona brought a big setback. So this will probably happen, but with a bit of delay, and also depending on the results of our pilot project.
So which bus technology did you decide to buy, and why did you decide on it?
We bought 12-meter buses with battery electric buses with overnight charging systems, because we did a study and we recognized that for the great area metropolitana, San Jose, so the metropolitan region, about nearly 90% of the routes it would be sufficient to have overnight charging.
Mm-hmm.
And so we wanted to have a pilot project that is representative. So also we chose routes that are not on carriles exclusivos, so bus rapid transit, because in Costa Rica there is only very few of them. So we selected very average routes because we wanted that the bus companies can see that this is representative, that is similar to their conditions. However, we also have a very, let's say, hilly terrain in the area. So this is always one of the critical points where the companies say probably it's not suitable for my route because it's too high, too steep. So what we are doing is with our third bus, we are doing tests on different routes in the country to collect data and to have more, to do more simulations also to show, okay, this battery is suitable for this route, maybe it's not. In the beginning, when we designed the pilot project, we thought, okay, maybe let's buy 3 different technologies to test them. Mm-hmm. But in terms of the opportunity to purchase, to implement the buses, that would have been too complex. So when we bought the buses, we also included a package of after-sales services that was important for the success of the project, including, for example, training to the bus operators, but also to firefighters and to everyone in the end that has to do with the buses, maintenance personnel. Mm-hmm. So far, I have to say, with our electric buses, we have only very positive feedback and very positive media articles. In Costa Rica, it has created very high visibility. So, for example, when the buses arrived in the port, there were media teams there waiting for the bus to come from the ship. When the bus was arrived in San Jose, there was another article. Of course, for the official handing over of the buses from the German to the Costa Rican government, there was, of course, a high-level event with the president, with the first lady, with the different ministers. Great. And then when the pilot project started in operation in February now, again, there was the president, there was the first lady, there were different ministers doing the first ride on the bus.
Great. Thank you so much, Andrea, for your time today and for sharing your experiences with us.
You're very welcome.
Congratulations to the colleagues in Costa Rica for setting in motion this transformation. It's great seeing long-term solutions being implemented.
Maybe cities do not have the know-how to plan and implement these new technologies yet. They may implement pilot projects, but there are no success cases yet when it comes to large-scale rollout of e-buses.
Luckily, we are just in the right city to prove you wrong. The public transport operator of Berlin, BVG, has taken big steps to introduce e-buses into their fleet. Already now, almost 140 e-buses are in operation And Berlin is not stopping there. Let's talk to them to see what they are up to. Dr. Hesse, thank you so much for taking the time with us. Tell us a little bit about where we are here today.
Okay, so we're here at Indira Gandhi Street. This is our currently our largest depot for buses. We have in total 6 depots right now, and we have started the whole journey of electrification here at Indira Gandhi Street. So also our first bus projects were done here, just because at that time it had, say, the largest space where you could also test things. That has changed by now, also partly due to the charging infrastructure. But this was the reason that we also continued here, just to build on the experience that we had before. Yeah, so we have basically the challenge that we need space distributed in the city to be able to also have short distances for the buses to go to the depots and back. So that would of course be easier for electric buses and also more economic. But due to the high prices of area in the city, it's quite difficult to find space. So we are also then fairly far out distributed in the city, and this of course also poses a challenge to us. But nevertheless, this is, as I said, say the first depot. We are now building the 2 more. They're in the planning procedure, and we're then also, in order to distribute our electric buses a bit better, we are also now partially changing or implementing electric infrastructure on other depots, so that we are not just based here, but also in some other depots, because then we have shorter distances to get to the actual lines in the city. So at the moment, if everything is here, then you have sometimes long ways to get to the actual line for the passengers, and you lose already a part of the battery capacity on the way. So this is something where we try to optimize the system now.
Did you plan from the beginning to have a large-scale rollout of e-buses, or were you only planning with demonstration measures to begin with?
We didn't plan the full target at the beginning. We actually started doing bus on alternative drives already quite a long time ago. So probably more than a decade. So we have tested already hydrogen buses, not hydrogen fuel cell, but combustion engine, with not so great experience, I have to say. Then we had already e-bus projects around 2013, 2014. And so then the question was, what is then the next sensible level? And we had a decision internally in the company to do a ramp-up phase for electric buses. And it was essentially just the idea, do something on a scale basis, so more than just 5 vehicles. 5 was the e-bus project that we did before, but something in the range of, say, 100 roughly. And so we said, okay, let's do 120 buses within 4 years. And then we basically see how we can learn a lot about how to organize say servicing, the driving, the planning, and all these things, and also repair of the vehicles, learn with this scale. And then sort of halfway through, we had the new mobility law of the Senate of Berlin, which basically states that all public transport has to be fully on alternative drives. Whatever that clearly means is a bit open, but it means essentially for us that we try to be decarbonized, so that became a bit clearer than on the way. But that target came halfway through. And then we realized, in order to get there, it's good that we have this ramp up, but we have to even speed up the ramp up. Otherwise, we are too slow to do then the next phases afterwards. So that means our actual initial ramp up phase, we finished that already 1 year earlier than we had initially planned. So rather than having 4 years, we sped up to 3 years and put another level on top, another 90 buses, which we now won't have in 4 years, but probably in 5 years. And so we basically already sped up the ramp up that we thought in the beginning was fast. Yeah. And then essentially now the way is clear, 2030, and we try to make modules on the way. So we try to basically organize the way how we plan the infrastructure implementation. That means we are thinking about depots, the areas of the city that they serve in terms of where the lines are, and then we try to make basically a sensible order of how we implement the infrastructure in these different depots also thinking about the implementation of infrastructure in the city, because that depends on the actual technology. If you can do with only infrastructure on the depot, or if you need it in the city as well.
And what was some of the feedback that you received from, let's say, drivers, passengers, but also from depot personnel?
I would say we have a lot of positive feedback. So both from the drivers and the passengers. So passengers say, for example, it's great, of course, that they decarbonize the buses, but they especially also like, it's new buses anyway, so that's a good thing in itself, but that they are much lower in terms of noise level. And it's also not only for the passengers inside the vehicles, but also the people living in the city. Of course, that's quite a relief that there's lower levels. And in terms of bus drivers, of course, there's fans of diesel technology, and these fans, they will probably take a bit longer time until they really buy into this technology. But there's others that just say, well, great that we get into this topic, and they like the acceleration of the buses. Something to note is that with an electric motor, you have a much better torque just from the beginning of when you start the engine. So that means it just feels speedy to drive them if you want it. Of course, you have to, as a driver, be careful what you do, because the passengers want comfort, not speed in terms of acceleration. But at least it feels dynamic in a way. So that's a good thing that we hear from the drivers. And then, of course, many things are just like with any diesel bus. In the end, this is not a spaceship; it's still a bus. And this is also what we see when there's issues with the bus. Very often it's just the basic things. It's not about the electric drive, but it's about doors, it's about anything that would happen in a diesel bus as well. And that means also that some drivers prefer certain brands of buses because they just like the way how it feels, and another brand is maybe a bit different, but that doesn't have to do with the electric bus or not.
Was there a particular process that you followed in choosing the right charging infrastructure for Berlin, and how did you do it?
That's a good question. Because we haven't chosen just one yet, and we also don't think that there is just one solution for the infrastructure. We've got a very large fleet in the city with different vehicle sizes, different requirements also in the city. We have, for example, solo buses 12 meter long, we have articulated buses 80 meters long, and we have also our double-deck buses, which are shorter than the articulated buses, but have even more passengers in them, so that we have some really compact vehicles for that many passengers. And that they are also used in different ways, where you then have to really test for some time to find out what is the best technology there. So, for example, this bus here is using opportunity charging, meaning that you have infrastructure to charge at the ends of a line, and that means you've got more flexibility if you need to recharge, because there's a high usage, for example, of the heating or the air conditioning, then you can do that within the city. So that's an advantage of that. You have, say, more stability of the operation. You don't need such a big battery on the bus, because you know there's infrastructure in the city. On the other hand, you need infrastructure in the city, and you need to be there when you have time to charge. So that means if you're stuck in traffic and your break where you wanted to charge is over, you have to go back, because you can't have the passengers wait. We have got fixed timetables here in Germany. We don't have, say, an interval where the bus is coming in 10-20 minutes slots, but we have a certain timetable, and if we are not there, then we basically get less remuneration from the city. So this is part of our contract. And that means you have to be sure that your time is enough to charge, and that you're getting there when you need to be there. So that's a disadvantage there. On the other hand, as I said, you don't need that big batteries. If you've got difficult weather conditions, easier to handle with this technology. We have many depot charging buses, the smaller ones. Advantages there, you can run them anywhere in the city. Even if you don't have charging infrastructure there, no problem. You can just use them wherever you want. But you have to have a big or large battery, large enough for what you want to do with them. So if you have very long lines or say the distances that you want to run in one shot with the bus, then you have to be sure that the battery is large enough. At the moment, looking at technologies for our double-deck buses. So we don't know yet which one is the technology for that one. We do a study on that. We want to understand the whole system. And then it's probably one of these that we just talked about. But we won't do the whole fleet with this, but test it on the way, maybe have 2-3 technologies. And then in a decade, we can still see where we stand.
And how easy or difficult was it for you to procure these e-buses?
I would say at the beginning, it was quite difficult, meaning that we would have liked to have more bidders in the process. It's probably also something to do with how the market develops, what requirements we put to a company, because when we buy buses, we have to ensure that the company also is able to deliver and to provide warranties and these kind of things. The market was very tight at the beginning. It's still not as great as we would like it, so we still think there's not enough offering, and that keeps the prices high. So this is something we would say it's still difficult to get good buses. We're not there yet that we can say it's as easy as with diesel buses.
And talking about procurement processes, which financing approach did you apply to procure buses?
Without these public support, so money from public sources, funding programs, it wouldn't be possible to do what we do at the moment.
So for my last question today, I'd like you to answer, what is your most important tip for other cities who are looking to roll out e-buses?
Just try it out. I think it's very important to be also part of this learning journey, because it won't be ready in a way that you can say, now it's served, essentially, you can now buy it and it works. It won't be like that. You have to do your own learning experience. Probably you have to find out what's really the best electric bus system. Always think about the system, not just the vehicle. What is the best system for the application that you have? And since the whole technology is still in a learning process, it's important to get into it right now to tell the technology companies also what you need. And this is something that we learned also the way. It's many things you wonder, it can't be true that the companies don't understand that. And simple things, for example, where would you put the plug of the bus, where you put the cable to charge? They just simply put it at the same location where they had the entry for the tank before. And you wonder, why? Is there a special reason? And then they realized, no, actually, it was just maybe it was the easiest thing to think about, but for us it doesn't work at all, because we would have it ideally on both sides, or maybe on a side where it goes to both directions, because we don't want to have this charging infrastructure just on one side. Infrastructure takes a lot of space, so you have to also find out how can I, and space is precious, especially in the city, so how can you build something that saves space but still works? And all these things have to be learned, and if you don't jump into this right now, somebody else will provide, or say will give input to the technology companies, and then it's a matter of luck if it fits your needs as well. But that's why we say we want to be part of this. Thank you, it was a pleasure.
And if you're still not convinced, the city of Bogotá is another great example for e-bus rollout. The bus manufacturer BYD has even designed a bus specifically for Bogotá.
Actualmente en operación en Bogotá, ¿y cuál es su objetivo a largo plazo para los buses eléctricos?
Perfecto. Nuestro sistema Transmilenio, el Sistema Integrado de Transporte Público de Bogotá, cuenta con dos componentes. El componente BRT, que son buses biarticulados y articulados que van por carriles exclusivos, y el componente zonal, que son buses, principalmente busetones y padrones, que atraviesan toda la ciudad. Los buses eléctricos adquiridos están destinados a el componente zonal del sistema. Este componente, en condiciones de no pandemia, moviliza alrededor de 1.500.000 pasajeros al día. Actualmente ya contratamos la provisión y la operación de 1.485 buses eléctricos. Estas contrataciones se dieron entre el año 2019 y el año 2021. Adelantamos procesos de selección, es decir, procesos competitivos para efectos de determinar quiénes serían tanto los concesionarios de provisión como de operación, y este fue el resultado. De estos 1.485 buses, ya se encuentran en operación 249.
Y en general quería saber qué beneficios aportan los buses eléctricos a los ciudadanos.
Bueno, sin lugar a dudas, beneficios ambientales en términos de reducción de CO2. Nosotros estamos estimando que estos 1.485 buses implicarían una reducción de aproximadamente 94.306 toneladas de CO2 al año. Asimismo, también conllevan beneficios en términos de calidad del aire. Estimamos una reducción de 37 toneladas anuales de material particulado, que es el contaminante criterio que mayores enfermedades respiratorias genera. Y en ese sentido, los beneficios ambientales y en términos de salud pública son bastante significativos. Adicionalmente, estos buses entran a ser parte de un sistema integrado de transporte público. Entonces, pues además de ser un aporte a una meta ambiental, también es un aporte a una meta de transporte, por cuanto estamos aumentando la cobertura de nuestro sistema integrado de transporte público en su componente zonal. Y esto trae una consecuencia favorable en términos de costos para los usuarios, por cuanto el usuario puede hacer transbordos entre los diferentes buses que están integrados al sistema con costo cero. Entonces también la entrada de estos buses representa un beneficio económico para los usuarios. Adicionalmente, estos buses cuentan con toda la tecnología para efectos de conocer en dónde se encuentra el bus y de esa forma optimizar la operación para Transmilenio y también planear el viaje para los usuarios. Esto nos permite tener información en tiempo real y poderle transmitir también esa información a los usuarios para que hagan un uso eficiente de su tiempo de viaje.
This is only a preview of the efforts more and more cities are making around the world. Public e-buses are one of the most sustainable ways to move in cities.
You are advocating exclusively for battery electric buses here, ignoring the benefits of other electrification technologies. So what about hydrogen or fuel cell buses for which charging infrastructure would be cheaper?
Well, let's change that. I know just the expert to talk to.
Hi Oliver, nice to have you in our TUMI TV episode. Thanks for your time.
Hi. Glad to be here.
So we will be talking about buses with alternative drives. And my first question to you would be, which different zero-emission bus technologies are there? And also second, what are the main differences?
Ja, vielen Dank für die Frage. Kann ich einiges zu sagen. Genau, ich habe ein paar Folien mitgebracht, um es noch ein bisschen bildlich zu untermalen. Genau, Technologieoptionen gibt es im Wesentlichen 3, jetzt auch mal farblich unterteilt. Zum einen die klassischen Batteriebusse, dann Batterieoberleitungsbusse, beziehungsweise auch die reinen Oberleitungsbusse und auch Brennstoffzellenbusse. Von allen gibt es sozusagen nochmal, ich sage jetzt mal Unterkategorien, die sieht man hier nochmal dargestellt und auch so ein bisschen ins Technische gehend. Also der reine Batteriebus, quasi elektrischer Antrieb mit einer Batterie als Energiespeicher. Der Batterieoberleitungsbus bzw. auch der reine Oberleitungsbus sind auch primär elektrische Busse. Je nachdem wie groß die Batterie ist, kann dann auch ein Fahren außerhalb der Oberleitung ermöglicht werden. In der Vergangenheit war das zum Beispiel oft über den Diesel der Fall. Das wollen wir jetzt aber dann zukünftig vermeiden. Genau, und bei den Brennstoffzellen-Bussystemen gibt es im Wesentlichen nochmal zwei Unterschiede. Es liegt zum einen sozusagen oder hauptsächlich in der Nachladefähigkeit und in der Größe der Batterie. Zum einen ist das ein Brennstoffzellen-Range Extender, sprich man hat eigentlich einen Batteriebus, der auch normal ladefähig ist, mit einer kleinen Brennstoffzelle und einem kleineren Wasserstofftank, um einfach die Reichweite zu verlängern. Und das andere ist dann der klassische Brennstoffzellenbus, der wie auch hier dargestellt sozusagen eine größere Brennstoffzelle, größeren Wasserstofftank hat und dafür nur noch eine kleine Batterie, dass die Brennstoffzelle in einem optimalen Betriebsmodus konstant betrieben werden kann. Genau, die Busse haben sozusagen unterschiedliche Reifegrade. Das ist rechts nochmal dargestellt. Also sowohl Batterie als auch Batterie-Oberleitungsbus kann man mittlerweile sagen, sozusagen in Serie. Wobei Oberleitungsbusse, da ist die Serienfertigung generell, glaube ich, so ein Diskussionsthema, weil die eigentlich in so kleinen Stückzahlen produziert werden, dass es eher auch jeder normale Oberleitungsbus als Manufaktur gilt. Aber es ist bewährte Technik. Genau, beim Brennstoffzellenbus kann man auch sagen, der ist sozusagen so an der Schwelle zwischen Serie und vielleicht noch Kleinserie. Und der Brennstoffzellen-Range Extender ist immer noch in der Entwicklung oder auch in der Erprobung, so in den Kategorien. Genau, nach der Frage zu den sozusagen Merkmalen kann man sagen, ein Batteriebus, da hängt im Wesentlichen von dem Ladekonzept ab, was verwendet wird. Also lade ich im Depot, dann vorwiegend mit dem Stecker, oder lade ich auf der Strecke, zum Beispiel Schnellladen mit Pantograph. Da habe ich einfach deutlich unterschiedliche Ladeleistungen, wie auch dargestellt, irgendwas zwischen 150 und 450 kW ist da sozusagen realistisch, wobei auch im Depot geringere Ladeleistungen möglich sind, wenn ich beispielsweise die ganze Nacht da stehe. Genau, und auch die Reichweite unterscheidet sich hier. Bei dem Bus, den ich auf der Strecke lade, habe ich so größenordnungsmäßig vielleicht 100 Kilometer, wenn mir das auch reicht, weil ich mehrmals am Tag lade. Und bei Bussen, die nur im Depot laden und dann möglichst mit einer Batterieladung einen Umlauf oder einen Tag überstehen, komme ich mittlerweile bei manchen Modellen so auf 300 Kilometer, aber gerade im Winter kann es auch durchaus noch mal weniger sein. Genau, beim Brennstoffzellenbus sieht das ein bisschen einfacher aus. Im Moment beide Technologien und alle Busse werden mit 350 bar Wasserstoff betankt. Die Betankung geht relativ schnell, in so größenordnungsmäßig 15 Minuten. Und je nach Konzept habe ich dann ungefähr 300 Kilometer, bei manchen auch 400 Kilometer plus als Reichweite. Genau, so viel vielleicht zu den technischen Eigenschaften der Busse.
Thank you very much for this great overview, Oliver. Maybe for a follow-up question, I would like to know, for which use cases do you think which technology is best suited?
Ja, das ist immer eine relativ schwierige Frage. Grundsätzlich kann man sagen, der Batterie-Oberleitungsbus ist zum Beispiel ein klassischer Stadtbus. Man braucht hohe Takte, dass sich auch so eine Oberleitung lohnt. Bei den anderen Technologien ist diese Frage tatsächlich nicht so trivial zu beantworten, weil es dann sehr von den individuellen Gegebenheiten vor Ort abhängt. Sprich, wie groß sind zum Beispiel meine Reichweiten, die ich tatsächlich am Tag habe? Wie sehen aber auch meine Umläufe aus? Habe ich beispielsweise ausreichend Platz im Depot für Ladestationen oder aber auch für eine Wasserstoffbetankung? Wie sehen aber auch meine Endhaltestellen aus? Kann ich da zum Beispiel Ladeinfrastruktur aufbauen? Oder habe ich vielleicht einen historischen Stadtkern, wo ich eigentlich zum Beispiel gar keine Pantographen irgendwo auf der Strecke errichten kann? Deswegen gibt es da tatsächlich nicht diese pauschale Antwort. Die Frage kommt aber relativ häufig. Deswegen gibt es da auch alle möglichen, ich sag jetzt mal, Unterstützung, weil das eben das Hauptproblem ist, was Verkehrsbetriebe haben. Dafür gibt es jetzt vom BMVI bzw. von uns entwickelt auch einen Leitfaden im ersten, sozusagen in der ersten Version erstmal als klassische Broschüre, sowohl online als auch print, wo man einfach nochmal so eine Art Entscheidungshilfe hat, für sich gucken kann, bei welchen Anforderungen könnte welche Technologie passen. Da spielt neben den sozusagen städtebaulichen und verkehrlichen Aspekten halt auch sowas wie die Topografie, aber auch das Wetter. Habe ich extrem kalte Winter zum Beispiel, dann funktioniert ein rein batterieelektrisches Konzept mit elektrischer Heizung vielleicht schlechter, sodass man sozusagen ja dann mehr Informationen braucht, um wirklich eine fundierte Entscheidung treffen zu können. Und deswegen auch quasi in der zweiten Version, gerade in der Erstellung, ist dann eine interaktive Entscheidungshilfe als Online-Tool, wir haben es jetzt E-Bus-Tool genannt, wo wirklich Verkehrsbetriebe auch ihre Umlaufpläne zum Beispiel integrieren können, für sich gucken, wo sind sie, also sprich die Standortdaten, und dann für ihren Umlauf schon erste Indikationen bekommen, welche Technologie passen könnte, und dann auch sozusagen alle Varianten nebeneinander gestellt, vom klassischen Batteriebus bis zu allen Brennstoffzellenvarianten, dass man sozusagen da einfach so eine Entscheidungsunterstützung den Verkehrsbetrieben mitgeben kann.
Great, thank you very much. This sounds like a very interesting tool also for our partner countries. But coming to my final question today, I would like to ask you as well, if you have any best practice examples of cities where each technology is already implemented.
Ja, da gibt es in Deutschland mittlerweile relativ viele. Ich habe jetzt mal so eine Karte mitgebracht, wo die verschiedenen Verkehrsbetriebe, die schon aktiv sind im Bereich Batterie, aber auch Brennstoffzellenbus, farblich markiert sind. Einfach auch nochmal unterschieden, gelb und orange dann die batterieelektrischen Varianten, blau Wasserstoff und sozusagen farblos die sich noch für keine Technologie festgelegt haben, also die noch nicht genau spezifiziert haben, wobei es bei denen in der Regel eher zwischen gelb und orange sozusagen noch die Abwägung gibt. Genau, wenn man jetzt so Best-Practice-Beispiele sich anguckt, kann man sagen, gibt es schon, glaube ich, einige, hängt auch jeweils von den Technologien ab. Ich fange einfach mal oben an. Berlin zum Beispiel hat im Moment die größte Batteriebusflotte in Deutschland mit knapp 140 Batteriebussen schon im Einsatz. Und im Vorfeld haben sie auch relativ viele Technologien getestet. Also vom ganz am Anfang Wasserstoffverbrenner, sie haben Induktionsbusse getestet, haben jetzt Depotlader, aber auch auf der Strecke, und gucken sich sozusagen links und rechts immer auch noch andere Konzepte an. Zum Thema Wasserstoff wird auch immer noch mit betrachtet. Das ist, glaube ich, sozusagen so ein relativ umfangreicher Ansatz, der auch alles adressiert. In Hamburg beispielsweise ist das ähnlich, auch Daten in der Vergangenheit relativ viel getestet. Die Flotte ist auch groß, ich glaube, es ist die zweitgrößte dann nach Berlin. Und was Hamburg zum Beispiel schon relativ besonders macht, wir haben einen ersten neuen Betriebshof nur für elektrische Busse gebaut, mit über 200 Bussen, die da abgestellt und geladen werden können. Das gab es so in Deutschland vorher auch noch nicht. Wir haben denen dann dafür auch an das Übertragungsnetz angeschlossen, sprich mit eigenem Netzanschluss, wo, glaube ich, auch relativ viele Verkehrsbetriebe mittlerweile vor Ort waren, um sich den anzugucken, um einfach schon mal ein Bild dafür zu kriegen, was kommen denn noch für Herausforderungen, wenn ich eben nicht nur die ersten 10 oder 20 Busse umstelle, sondern wenn ich gleich in den größeren Stückzahlen mit 100, 200 Bussen denke. Deswegen, glaube ich, muss man hier dann auch Hamburg nennen. Genau, um jetzt mal von den Batteriebussen wegzukommen. Köln hat seit 2011 Wasserstoffbusse getestet, hat im Wasserstoffbereich mit die größte Flotte in Deutschland aktuell mit ungefähr 30 Brennstoffzellenbussen. Zum sagen, ist noch nicht in den Stückzahlen, wie man batterieelektrisch ist, aber nichtsdestotrotz haben sie schon viel in dem Bereich an Erfahrung sammeln können, haben sozusagen auch gute Erfahrungen gemacht, deswegen sind sie bei der Technologie geblieben, sodass das eigentlich ganz gut für den Bereich Wasserstoff zu nennen ist. Genau, und um sozusagen alle Technologien hier auch nochmal zu platzieren, in Solingen gibt es ein sehr umfangreiches Oberleitungsbusnetz, und Solingen hat in einem relativ umfangreichen Forschungsprojekt dann auch versucht oder erfolgreich umgesetzt, einen Batterie-Oberleitungsbus erstmal sozusagen mit zu entwickeln und dann auch zu erproben, um so auch den elektrischen Buseinsatz deutlich noch auszuweiten, ohne in größerem Maße das Oberleitungsnetz auszubauen, weil das tatsächlich mit relativ hohen Kosten verbunden und teilweise auch recht schwierig. Und da bietet sozusagen dieser Batterie-Oberleitungsbus ein gutes System. Aber das waren jetzt sozusagen nur 4. Ich glaube, es gibt noch viele weitere. In der Karte sieht man, es gibt doch einige Punkte mittlerweile. Und es kommen tatsächlich auch immer noch neue hinzu. Also genau, es gibt, glaube ich, sehr viele Best-Practice-Beispiele. Und man muss auch sagen, das ist sozusagen so vielfältig das Thema, dass man sich wahrscheinlich für einzelne Anwendungsfälle auch immer noch sozusagen einzelne rauspicken kann, die dann für den individuellen Fall ganz gut passen.
Perfect. Thank you very much, Oliver, for this great overview of best practice examples and also for a very thorough explanation of the technology.
Thanks a lot for clearing this up. Are there any open points we haven't addressed to demonstrate the sustainable value of e-buses?
E-buses run with electricity based on fossil energy resources are no better than diesel buses for the environment.
Sector coupling and renewable energies are relevant factors when it comes to the sustainability of e-buses. So let's take another moment to look into the issue.
So modernization is an important issue that you've just mentioned, and it brings me to another question or another sector of questions in terms of sector coupling. Because I think in Costa Rica, if I'm not mistaken, at least 98% of the energy comes from renewable energy sources. So I'm wondering if you've thought about the connection of these renewable energy sources with the mobility sector, especially the e-buses that are being operated now and potentially additional ones in the future.
Yes, of course. I mean, this is one precondition that also drives the prioritization for electric mobility in Costa Rica. And with regard to our bus project, we never, for example, had the question whether we want to go for hydrogen or gas or batteries. That was set from the beginning because it's a national priority to develop electric mobility also in public transport. And this is, for example, one of the targets in the National Decarbonization Plan. In the big range of plans, so it's clear that the government wants to go for electric mobility, especially for this reason because there's a lot of electricity and clean electricity, which many times also there's an oversupply during the night because there's a lot of hydrogen energy that is used here, more than 70%, and the regional nets. Regional grid doesn't exist yet. So if there's an oversupply, the energy just gets lost. And so promoting electric mobility is perfect because the buses can charge overnight and they can use this energy that is available very cheap. And also one of the achievements in the, let's say, in the implementation and the preparation of the pilot phase is that the tariff for charging electric buses has been defined newly and it's very, very low. So you pay less than 10 euro cent per kilowatt hour to charge. And this is fantastic. So this makes it much more competitive to have electric buses compared to diesel buses. And we receive now the first numbers of the bus company that is implementing the pilot project, and that is very promising.
If you had to give a tip to other cities, let's say decision makers or administrative colleagues working in cities, what would you recommend them to try to establish beforehand to make it more easier for them as a city to procure e-buses or to encourage the procurement of e-buses?
I think this is one key factor to start working with the electricity provider to ensure that you have the necessary conditions to charge the buses. Another important factor, if you want to start a pilot project or promote electric buses, is probably to try and bundle the purchase of buses so that in the end you don't ask for or tender out 3 buses, but maybe 20, 30 or 50. So in the end, everyone gains from it. I would say it is essential to achieve institutional alignment from the beginning, because on the way you will identify different hurdles, and therefore it's really good to have everyone on the boat, everyone communicating with each other and having a defined target, a shared target that this group wants to achieve. Because having the targets in a policy document is one thing, but having the buying, having the ownership of different institutions is a different thing. So this is something I would certainly recommend. Of course, you need a bus company that wants to move forward with this topic, and then you have to create the conditions. For example, the bus tariff here in Costa Rica. There was no bus tariff for electric buses because the tariff is defined by a calculation formula that includes the diesel consumption. Of course, if you don't have diesel consumption, that doesn't work.
So you've mentioned that you're satisfied with the range of the buses so far in terms of what the demands of the different routes are. What about other factors? You've mentioned media and public attention. Are you happy with how the pilot project has so far been implemented, and do you see positive effects, or are there certain things that you would now in hindsight say to change in the beginning?
The bus companies, they are very proud, they're very happy. Also the bus drivers, they are really proud that they are the first train that they can ride the bus, and they are very satisfied how easy it is to manage to drive the bus, and also that the users in the end, they are more than satisfied. They are very excited when they see the bus, and normally it's not such a pleasure to take the bus because they are sometimes dirty, they are old, so it's not the most popular thing. But with these electric buses, also because they have been in media a lot, and it's very well known, even though it's a small pilot project, but it's also a small country, you have to say. But people are really excited, and it's very comfortable because the traditional buses they use here, they don't have a low floor entrance. So it's also more difficult to enter for older people, for people with baggages. And our buses have low floor entrance. They have more space, less seats also. Let's see how this impacts the satisfaction. Because before, the minimum seating number in buses was 42. Now we have 33. Yeah, so we also had to get an exception for that. This could be a factor that could be criticized, but so far everyone is very happy that the buses are so quiet, that they are so clean and beautiful, because we also made a contest with students, with students like the age of 11, that they could send in pictures how the buses should be designed. So more than 100 students participated, and we organized this contest, this competition, together with the Ministry of Education and with the School of Design. And in the end, this was also something that was received very positively. And now the buses are designed with a drawing of a child, with some images and symbols from Costa Rica. So it also looks very, very pleasant. And in the end, the bus also has some features that are nice to have, like USB chargers and Wi-Fi. So that is nice. In other cities, this is standard already, but in Costa Rica, yeah, some of the innovations are a bit delayed. And the new buses represent a little bit what modern public transport should be.
Entonces, también un tema que es muy interesante de hablar es el tema de acoplamiento del sector o de los sectores movilidad y energía, y por eso me interesa cómo funciona en Bogotá. Tenemos entendido que los buses eléctricos se cargan con fuentes renovables, y podría decirnos de dónde proviene la energía y cómo funciona en la práctica el acoplamiento de los sectores en Bogotá. Gracias.
Por supuesto, la generación eléctrica en Colombia es la sexta matriz más limpia del mundo. El 68% se deriva de la energía hidráulica. En ese sentido, pues es bastante limpia nuestra matriz energética. En relación al sector, pues tenemos la generación, la transmisión, la distribución y la comercialización de la energía. La integración entre estas 4 etapas permite garantizar el suministro pues, requerido por nuestros buses. En este proceso es de vital importancia pues el tema de infraestructura de recarga ha sido una de las consideraciones más importantes regulaciones de nuestros procesos de selección y sin lugar a dudas un factor determinante para efectos de avanzar en la implementación de buses eléctricos en nuestros países.
En su opinión, ¿por qué es crucial el acompañamiento de los sectores de la energía y la movilidad?
Sin lugar a dudas, en estos procesos es muy importante tener en cuenta a todos los agentes que intervienen y entender muy bien qué intereses tiene cada agente, cuáles son las proyecciones de cada agente. Entonces aquí estamos hablando de fabricantes, estamos hablando de operadores, estamos hablando de las entidades o empresas encargadas de la generación, transmisión, distribución y comercialización de la energía. También estamos hablando de los reguladores. Creo que es fundamental tener una coordinación entre todos estos actores para que un proyecto de buses eléctricos sea exitoso. A manera de ejemplo, es muy importante tener claras las fechas de ingreso o de exigibilidad de buses eléctricos en las ciudades para efectos de que la industria se prepare para poder cumplir esas fechas. En Colombia vivimos una transición muy importante en ese sentido. En el 2018 no teníamos tanta regulación al respecto. Y a partir de las renovaciones de flota que iba requiriendo el sistema, pues esto dejó en evidencia que era fundamental establecer hitos claros de entrada de buses eléctricos desde el punto de vista normativo y a partir de eso se empezaron a expedir una serie de normativas tanto desde el gobierno nacional como desde el gobierno distrital tendientes a justamente establecer esos hitos, a mandar un mensaje claro a las industrias para que se preparen y puedan darles cumplimiento. Ese proceso diría yo que es fundamental.
El uso de energías renovables ya es más barato que la electricidad convencional como diésel o algo así, o es más caro, como es en Bogotá.
Bueno, las energías renovables, particularmente la energía, los buses que funcionan con tecnología eléctrica, tienen una mayor eficiencia energética. Esto quiere decir que pues, tienen una menor pérdida de energía en forma de calor, tienen una autogeneración por frenado regenerativo y esto lleva pues, a una menor necesidad de abastecimiento de combustible y por supuesto a una menor necesidad de costos asociados a este tema de abastecimiento. Hay otros desafíos, como por ejemplo la inversión en el CAPEX del vehículo, que aún continúa siendo alta y pues ahí es necesario buscar mecanismos o alternativas de financiamiento que viabilicen la posibilidad de compra de este tipo de buses.
With this last impression from Bogotá, we are now back in Berlin to tell you goodbye for today and send you off. Thanks a lot to all the experts who helped us put this episode together and who provided their knowledge. I hope we could convince you that e-buses are a sustainable way for cities to decarbonize. Of course, we know that there are many more questions for decision makers to answer when implementing e-buses. And that's why our second episode on e-buses is going to look further into the issue of what to consider and prepare for in cities to roll out e-buses. Until then, do check out our website for more info on the topic and don't forget to take our quiz and gain some TUMI points. See you next time.